This video is for section 1-1, sets and their relationships. Because this is the first lesson for Algebra 2 this year, I want to mention one thing. The video only highlights the information in the textbook. It doesn't include everything in the section. So along with the notes that you take during this video, you should also read the section of the book that goes with this and take a look at any other vocabulary words that are discussed, as well as any worked out examples that aren't in the video. Let's start. Two fundamental math concepts that we'll use in this section are membership in a set and equality. The objects in a set are called members or elements of the set. So please fill in the word elements on the note page. The symbol used in math for is an element of looks like this. It's kind of an E, but a little rounded. The symbol that means is not an element of is that same symbol, but with a slash mark through it. So if you ever see this symbol, what you actually speak is an element of. And if you ever see this one, you speak is not an element of. A set can be described by listing its elements within braces. So on this line, I'd like you to draw braces. They are fancy parentheses. They look like this. A set can also be described by giving a rule that specifies whether an object belongs to the set. And here's an example. In braces, here's a rule, the students in this class. So instead of listing everybody's name, we can write out this brief statement that describes all of the elements of this set. Next vocab concept is equal sets. Two sets are equal if they have the same elements. Let's make an example of this. Our first set, let's say, has the numbers -2, 0, 1, and 6. That would be equal to this set, -2, 0, 1, and 6. For two sets to be equal, they have to have exactly the same elements. Now let's create a non-example. Let's say our first set contains the numbers 10, 11, and 12. And another set has the numbers 10, 11, and 13. These sets are not equal. They don't have exactly the same elements. Next vocab words are finite set and infinite set. A finite set is a set whose elements are countable. As an example, this is a finite set. It has only those 4 elements. Here's an example of an infinite set, the set of integers. If you tried to list out all of the elements that are in the set, you would never reach the end of that list because the integers are numbers such as 0, 1, 2, 3, 4, 5, 6, and all of the negatives of those numbers. That list of numbers is unending. It is an infinite set. Some sets of numbers that we'll use a lot in algebra include the set of whole numbers. On the note page, let's list out the first several whole numbers. It starts with 0, and the rest of them go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on forever. To show that, you can write ... Next, let's show several of the integers. So you make a brace and then list a lot of the integers. I'm going to start with some negative integers. And I'm going in order and not skipping any as I do this. The integers will continue forever in the positive direction, but they also continue forever in the negative direction. So I'm going to put ... at the start of my list as well. Next example, non-negative integral multiples of 5. Let's list those. So non-negative, we don't want to have any negative numbers in our list. We want to have multiples of 5. So the first multiple of 5 that's non-negative would be 0 times 5 makes 0. Next, 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15, and so on forever. Final example, the perfect squares of the integers. Perfect squares are numbers that are used a lot in algebra class. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16, and so on forever. If you square a negative number, the result is positive. So this list of numbers also includes the squares of the negative integers. The next vocabulary word is subset. Set A is called a subset of set B if every element of A is also in B. The symbol that means subset looks like this. Here are some examples involving subsets. The set of women is a subset of the set of humans. So when I see this symbol, what I'm actually speaking is a subset of. The next two examples are not finished. The set containing 2, 4, and 6 is a subset of. Let's fill in a set that has 2, 4, and 6 along with some additional elements. One example could be 1, 2, 3, 4, 5, 6, and 7. There's all kinds of different possibilities that you could write in here. But for the example we created, 2, 4, and 6 is a subset of that list. Now I've made another example using 2, 4, and 6 again and left another blank spot. This time let's create a set and use that other way to define the set where you write out a rule instead of actually listing elements. So one rule that we could use is we might say even numbers. There's lots of possible things we could write in those braces, but by saying even numbers, we create a true situation. The set containing 2, 4, and 6 is a subset of the even numbers. Now, next vocabulary word is empty set. This is used when a set has no members. And the symbol for empty set is like a 0 with a slash mark through it. So if you ever see that symbol in the book, it means empty set. Here's an example problem. List the elements in the set of vowels that are between the letters B and D. So we want to list any vowels between B and D. There aren't any. And so you would answer such a math question by writing empty set. That indicates there is no answer to that question. In algebra, the sets of objects we're most concerned with are called numerical expressions. These are symbols that designate a number. And I have 4 different numerical expressions shown in the video. All of these are symbols that designate a number. An equation is a statement of equality between numerical expressions. Here's an equation, 3 equals 7 minus 4. Here's another equation, 7 minus 4 is equal to the square root of 9. We could write all kinds of equations that indicate that 2 different expressions are equal to each other. Finally, we have the vocab word inequality. This is a statement that 2 numerical expressions are not equal. As an example, we could write 3 is not equal to 4 plus 1. This is an inequality. Let's summarize. In this first lesson for Algebra 2, we reviewed some vocabulary words that are going to be used in the class this year. One concept was sets of objects, where the objects that we'll use in math class will tend to be numbers and numerical expressions. We also learned some symbols that will be used in math class this year, such as subset, element, equals, and is not equal.